Euclid's Elements, Book 1, Proposition 6. If in a triangle two angles be equal to one another, then the sides that subtend or are opposite those equal angles will also be equal. This proposition is the converse of Prop 5. Remember, Prop 5 says if we have two equal sides, we can prove equal angles. Well, in this case, we're starting with, we have equal angles, and we're going to prove that the sides opposite or that subtend those angles are equal. So our given in this case is, so let's have triangle ABC. Our given is that angle ABC is equal to angle ACB. And from that, we're going to prove, right, that the sides opposite or that subtend those angles, AB is equal to AC. So I'm going to start off by making the claim, hey, I say that AB and AC are equal. And then I'm going to assume for the moment that it's not. For if they're not equal, then one of them is larger, right? If they're not equal, then they are unequal, right? Those are the only possibilities. Either these are equal or they're not. If they're equal, we're done. If they're not equal, then we need to show that it leads to some kind of contradiction. This is known as a proof by contradiction. We're going to start with some assumption and show where that assumption leads to a contradiction. Because it leads to a contradiction, we're going to reject the assumption and therefore go back to our original claim. So here's our original claim. If not, then they're unequal. So this is going to be my assumption. Okay, well, let's assume for a second that they're unequal, which means one of them is greater. So 1 is greater, right? Either AB is greater than AC or vice versa. So let's just pick one at random. Let's say that this is the case, that AB is greater than AC. Okay, so that's our assumption. AB greater than AC. Well, if AB is greater than AC, we can always cut off from the longer a piece equal to the lesser. So let's cut off a piece of AB, namely we'll call it AD, or no, BD. We'll make BD equal to AC. And we're doing this with Prop 3, allows us to cut off from the longer a piece equal to the shorter. So now DB and AC are equal. Now let's join CD, which we can do. We can join CD because of postulate 2. Postulate 1 allows us to join any 2 points. Now let's look at these two triangles. All right, I'm going to draw a blue triangle here. Here's a blue triangle. All right, so we have triangle DBC. And we have triangle ACB. And I'm going to make that, I don't know, let's just make that red so it kind of pops. All right, we're going to make this one red. All right, A, C, B. All right, and we've already shown that DB, right, is equal to AC. And we know that this angle here is equal to this angle here. And BC is common to both of those. Therefore, you can see we have side angle side, side angle side, and we know, therefore, that these triangles, namely triangle DBC, is equal to triangle ABC. And this is from our side angle side proof, which is Prop 4. Well, what's the problem with that? Well, we're saying that this blue triangle is exactly equal the base to the base, so we would say that the bases are equal, and the triangles as a whole are equal, and all the corresponding angles are equal. But we're saying this blue triangle is equal to this red triangle. But it's very clear that the blue triangle is only a part of the larger whole of the red triangle. And so we're basically saying that the part of this blue triangle is equal to the whole. Can the part be equal to the whole? No. But that's what we're saying. We're saying that the part is equal to the whole. But we know from common notion 5 that the whole is always greater than the part. So this is a contradiction, that the part can be greater than the whole. What led to that contradiction? Assuming that one of these is unequal. Therefore, that assumption has to be thrown out. They cannot be unequal, otherwise this contradiction arises. If they're not unequal, then they must be equal. Therefore, my original assertion holds, because to contradict it, to assume otherwise is to lead to a contradiction. Therefore, this original assertion must be true. Therefore, if we have a triangle where the angles are equal, then the sides opposite those angles, or that subtend those angles, will likewise be equal.